Okay, it looks like folks are starting to come in from the last session. Welcome to our next tech demo session with our sponsor, Iconics. My name is Morgan Ford, and I will be serving as your moderator today. Just a few housekeeping rules before we get started. This session will be 30 minutes in length total. You are encouraged to utilize the question and answer tab to submit questions throughout the presentation, which will be addressed by the speaker at the end of the program. The Q&A tab, folks, is at the bottom of your screen. Please utilize this for questions as it is easier for us to keep track of them. If you would like, you can find a copy of the PDF of today's presentation in the auditorium where you logged in, should you wish to download it for future reference. And in case you missed part of today's program, it is being recorded and will be made available for 30 days after the live event to all registered attendees. At this time, I would like to introduce our speaker, Jotham Kilday, with Iconics. He has worked with Iconics for 10 years in roles and responsibilities which cover a variety of industries. His primary responsibilities have been centered around developing solutions, leveraging Iconics and partner products for specific customer applications. He is also involved in guiding the future development and innovation at Iconics in order to adapt to new requirements in smart manufacturing and analytics. Thank you for joining us today.
Thank you, Morgan. And thanks everybody for joining the session today. So Morgan said I'll be kind of guiding you through some of the discussions on this. Just to start us off, I wanted to give just a brief overview of who Iconics is, where we're coming from in this discussion. So Iconics, we've been a software-based company. It's purely software that we work with. We're based in Foxborough, Massachusetts for almost 35 years at this point. We do have a very international focus. About half of our business is in North America, half of it outside of North America. So we do projects all around the world. As part of that relationship, we have a great long-standing relationship with Microsoft as a partner, as a development resource, as a marketing resource. We'll see some of the examples on that in a little bit. We're also a group company of Mitsubishi Electric. They acquired us maybe about 2 years ago now. We've had a long relationship with them before that, but the acquisition happened 2 years ago. It's been a great boon to our business so far. We come into it with a lot of knowledge of software, SCADA, data analytics type things. They obviously understand a lot of the world of hardware, manufacturing automation, and manufacturing systems. So it's been a great relationship for that purpose. Obviously, for the discussion today, we're talking a lot about the manufacturing intelligence related topics for our solutions. Of course, we do play in a lot of other spaces. So if this is something that has some relationship to your business, definitely talk to us about it. But we also do a lot of things in energy smart buildings. These are smart campuses, smart hospitals, whatever. A lot of utility applications. So oil, water, and gas. Oil and gas, water, power transmission, and then also getting into things like infrastructure. So highways, bridges, shipping, airports, a lot of different applications that we touch on. So that really does cover a lot of different spans of applications. Usually what I point out is that obviously not all of these are going to apply to your application, but there's different expertises that different industries bring to the fore. And what part of my role and my team's role within the organization has been especially about taking the best practices from different industries and different applications and figuring out how they can be applied. There's a lot of good intelligence and good thought about how to do systems efficiently and effectively in these different places. So we try to use those best practices across the applications. Just kind of give you a taste of some of the applications that we work with. As I mentioned, Microsoft on the bottom left, they are a partner in many ways. We also do the building systems and building automation for their campus in Washington and many other campuses around the world. But we also play in, of course, machine builder applications, oil and gas, as I mentioned. We talk about different automotive tier 1, tier 2, and so on, suppliers, the full gambit of what you can imagine. These are just some of the recent examples. Also, at the top left, we talk a lot with the US government, in particular, projects involved in the Pentagon, DISA, and so on. Things that obviously would have a very high standard or expectation for security. So that's something that we take very seriously in our product development. Now, what we're here to talk about today is manufacturing intelligence, smart manufacturing. I like to usually go through the story on discussion of OEE and what is the primary motivation for a focus on an OEE. Look at what are you focused on in your organization. Now, maybe you've heard this or a similar story before, but the importance of this comes in from the aggregate benefits. So if you look at a hypothetical example of a widget manufacturer that's making, maybe just 3 cents profit per device, per widget they can make 200 per minute. If you add that up over a 5-day, 24-hour shift, you're looking at, upwards of $7,500 per day of potential profit. If you're in theory running 100% of the, optimally, you're 100% available, 100% performant, and 100% quality. You never make a bad part. Ideal scenario, 100%. That would be aggregating up to over 18,000 per year if you could get 1% better. Just moving 1% further along that metric. Obviously, if you're doing 1%, why not 2, why not 5, 10, 15? Looking at the aggregate, there's serious money and there's serious opportunities to be made in focusing on OEE, really drilling down into those availability, performance, and quality metrics, and understanding what's going on in your processes and what's driving the opportunities for savings. So some of the things that we like to focus on when we deploy solutions with our software are going to be asset utilization, understanding and really getting a good grasp on what is the machine, what is the asset that you're using, how is it meant to be used optimally, what are the detractors from that, what's causing bottlenecks, what's causing loss of opportunity in that utilization. That's key to understanding it. Then also looking at the existing infrastructure and pinpointing where these downtime events come from, what changes might be possible to increase those numbers, improve the utilization of the equipment you already have. Again, we're a software company, so we're not usually focused on you need to buy new hardware. It's more about what can you get and what can you optimize out of the equipment you already have. Also, that comes into a lot of cross equipment and cross line correlations. So looking at the performance in similar equipments across different lines, different facilities, a lot of cross-sectional analysis on that. Obviously, the overall goal typically being lowering the total cost of ownership while driving up the overall productivity and capability out of your equipment. So with that aside, I wanted to get into a demonstration of what the software would look like. This is something that is rather typical for a scenario. So we'd be looking at process data from typically PLCs. This is most commonly for us going to be an OPC UA or a Modbus interface. Now, we also typically will bring in some MES layer data. That would commonly come to us via a REST API or an ODBC connection. So different protocols used, but the end goal is the same. Bring that data together so you can start driving some insights from that data. In this case, it's a cloud-based system. This is something we host in the cloud, but obviously we've been around for 35 years now. We certainly are familiar with on-premise applications as well as cloud-based applications. It really depends on what's appropriate for a particular project. Just so you understand, today we're looking at cloud-based deployment, and very common for our applications, we have browser-based visualization. So since I mentioned that, let's go ahead and have a look at that now. So pull that up. What we're looking at here is, first and foremost, this is our typical deployment of our software. Browser-based, I'm just using this inside of a Chrome window. Quite common, whether it's on-premise or cloud, that your clients or interface of how do you access and read out the data from a system going to be through this web browser type interface. Very flexible. You can put whatever you want in the UI and how you navigate. It just runs thin client, so you don't have to think about it of how do I deploy out new versions and updates to the users. They just connect to that URL and it's coming from that server automatically. Also, I pulled up particularly from this example a good a flow diagram of what this application is simulating. This is it's kind of an amalgamation of projects. I obviously am not connected to a real customer today, but this is a roller chain manufacturing line. So just as a reference of what we're looking at here, I picked it because it does have some interesting aspects of, it's a non-linear process. So as you can see, there's sharing of utilizations between the presses and the heat treatment furnaces. It's not always going to be a step-by-step process. It makes it a little bit more interesting for how you analyze the data. Now, also, this is something that would play perfectly into the higher level multi-site analysis. This is also something that we do quite a lot in our larger applications, is really deriving insight from the data across multiple facilities and trying to pick apart and figure out why is one site performing better than another site in certain circumstances. Sometimes these might be, legitimately attributable to different problems. Otherwise, it's something you can drill into and find some really interesting insights. The important thing to note about that is that quite frequently, you'll find that there's not going to be a consistent protocol in use across all sites. Different sites have different MES systems, they have different PLCs, they have different hardware manufacturers and vendors. So having a flexible platform and a common interface, and that's why we use so many open protocols, that's going to be key to being able to derive that insight and being able to get into that data. Ultimately, what we're usually striving towards is normalizing it and abstracting away the nuances of what original data source it came from, to instead something like this, where you can see just a high level understanding of what's equipment's running, what's the status, what's the downtime, what's the performance of all these pieces of equipment, regardless of their manufacturer or their data protocol you're using. That's what you're trying to drive at, is something that really abstracts that away. Obviously, it's important for integration to understand those things, but when it comes to the visualization, you want something that's just going to be a uniform consistency of interface. Also, kind of just an interesting thing as far as how do you figuring out where's the appropriate place to do different drill down. Here, I just enabled one of being able to filter and query the data in real time based upon batch ID. Is something that could be useful for filtering this data to see how that changes the information that you're seeing across different metrics and different cross sections of your data. So another thing that is also maybe in part a holdover from how Iconics we do a lot of SCADA-based applications is that we tend to like to see something sort of like this. This would be a top-down plant floor view and visualization of all of that data in real time. Obviously, this is something you might see from a more supervisory level, but we find it's very useful in these projects because it has some interesting insights. Obviously, there's going to be a lot of decluttering, we call it, which means that you don't necessarily need to see all the data all the time. That's why certain things will be hidden behind different visualizations here. I, as an administrator on the system, have access to everything, but very commonly what would happen in a real deployment is that this would be filtered according to the security of who's logged in. Maybe certain, the quality assurance users will see certain sets of data, maintenance team will see different pieces of equipment. Depending on what their responsibility or role is within the organization, you might have a filtered look at that view. Going even a little bit further down, as far as the individual operator, what you might see at an operator at a process cell, something like this is not uncommon for how you do the visualization. The reason I picked this particular view is a little bit more understanding about how you capture all the raw data that's needed for proper OEE analysis. I would typically say, coming from that software perspective, in an ideal scenario, all of the availability, performance, quality events would be something that is automatically captured by a PLC, right? That requires no manual input, no man hours to adjust the data. Ideally, it's something that can be captured automatically from the PLC. Ideal, not always the case. Frequently, what you'll have is some sort of hybrid where you have some things that, yes, can be captured automatically. You can capture downtime events for certain machine-related failures. There's a lot of other situations where you need a manual input. The operator has to provide information into the system to explain why was there a downtime event, maybe partition that time to say a certain amount of time was used, waiting for maintenance to come over and fix the problem. A certain amount of time was waiting for the actual repair to occur. A certain amount of time was used on the startup cycle before it is ready to run again. All that sort of stuff with downtime. When you really want to track and do so delicately, it's important to have all those different slices of information attributed properly. So in this view, it's a simple UI, but you have historical downtime events that have not yet been attributed to a cause. The machine doesn't know why the downtime occurred, the operator does. So this user interface would allow them to click on those and annotate those. That could be happening immediately. It could also be something that happens after the fact when they have a spare moment or at the end of the shift. Maybe they would go in and attribute those events so that the end result, the data set that goes into the final OEE calculation, is accurate and it's complete. This is a simple example. As I mentioned, there's a lot of other exceptions or nuances to the rule about how you capture partitioning of that into different time slices and what have you, but just to give you a quick example. Let me jump over to another thing related. So we talked a little bit about availability. I also wanted to show you guys some things quickly on quality. So this is where we typically would get into things more related to statistical process control. So if you're not familiar with this, the idea in a nutshell is taking the measurements, the performance of equipment over time, divvying those up into subgroups and samples, and then doing analysis to figure out the deviation and standard deviation and range of those values from the trending line as well as the specification and control limits for that, and seeing, as you can see, outliers to the data set. I've deliberately made this data set work with some noisy data so you see what happens when there's some poor performant data. This is something that is, rather than analyzing the data at the end of a shift or at the end of the day and saying, oh, we did something wrong there, we could have done something better. SBC is really about being able to capture at the moment something goes wrong and correcting for it quickly. Because you get those immediate events when something is out of the control limits, those alarms can be notified to people immediately to take corrective action. You don't have to wait until the aggregate data happens much later in the fact to realize something went wrong. So a lot of what we talk about for cost savings improvements is all about detecting issues, but how quickly can you detect and react to those issues? So we see the SBC as an important way to get at that data quickly and at the time it occurs. Now, let's see, other things. I'm just kind of jumping around between different roles of what you might see in the organization. Again, not everybody would see all of this data necessarily. You could, it's up to you. This, for alarm visualization, might be something you'd see more from a maintenance perspective, where, again, a lot of times data coming from PLCs, from RTUs, you capture that information and be able to take action on it. Sometimes these failures are things that could be corrected just entirely from the visualization. You don't actually need to go to the equipment. You can just correct the performance metrics from here. Other times it might be instructive of what needs to be corrected and maybe what equipment or what parts you might need to bring with you to that particular event. So I just clicked into one of those examples, and this interface is all about drilling into the real-time data for that equipment and maybe seeing what's going on with the equipment leading up to that failure. And that might be instructive to the maintenance person that's going to go out to actually fix that issue. So another great way of how do you extract some useful insight out of that information and data. Since we talked about some of the availability and quality, I did want to jump back to some of the OEE things. So back to our flow diagram here. A lot of times, honestly, what we use, this is something that you actually could see for type of an and-on display, where we just have a card view, we call it, where you have a visual indication of what the performance is on different process cells or different lines. We also do like a list view variant, however you wanted to view that data. If it's an and-on, obviously that's kind of the level of detail you'd show. In this visualization, you can actually drill in further and have a look at the detailed data. This is the end result of bringing in that data from the automated systems, from the manual users, but it's also for us frequently something that you would want to think about bringing in those third-party MES systems. So maybe there's a dedicated scheduling service that you work with or a batch management system. How do you get that data? How do you normalize it in such a way that we can merge it with your real-time process data, with your manual input data from operators and users, so that you can have a complete picture of the application is really what we're driving at here. Behind the scenes is a tool we call Analytics BI. It does a lot of this cross-sectional data analysis so that you can query from data set A to data set B to data set C and it all meshes together well. Now, the visualization on this is pretty simple. A lot of times when we deploy projects, people would predominantly be looking at this as a real-time data set. If you're in an environment where you might have, the morning meeting to say, hey, what happened yesterday? What are we going to do to do better today? Sometimes the traditional model is let's run a report and get that, and then make sure that report's ready for our 7 a.m. meeting. Increasingly, we see just if you have this dashboard, you have this capability, you might just use this live. You might just be able to go in here and see the data live. What you get beyond that from what you would have in a pre-generated report is obviously the navigation capabilities. I can change the time series. I could change the data set or the line that I'm looking at in real time. That's a huge benefit if you're trying to really analyze. You don't want to be stuck saying, well, I wish I knew that, but I didn't think to include it in my report for my morning meeting. Having a real-time dashboard just makes that easy. Obviously, if you do need the data and the raw data, that's a lot of times why that report gets made. Frequently, what we'll do is have in the dashboard the direct export. So I just hit a right click on that chart, and now I can export it to the various formats that I might need to use to get that data out if I did so need that. That's kind of an ad hoc report. We do also have a tool, and you'll utilize it quite a bit for pre-generated reports. The difference here is that you might use these reports if you needed to have a structured format of the data that is kind of a known report that's management or whoever's expecting it. You can obviously parameterize it. So it might be parameterized based upon batch or based upon machine or what have you. That all's done in the reporting engine, but I just wanted to point out that there's a mixture of maybe I want a pre-generated report that gets emailed to people daily. Maybe I also want to see that data in real time through a dashboard. So I kind of jumped around a lot on that, but I think that was a quick, good overview of what sorts of things we're working with in our application. So with that, I'd like to turn it over to some questions, if anybody has any curiosities.
Okay, awesome. I just wanted to remind everybody to please make sure they're putting those questions in the Q&A box at the bottom of the screen. We have one in here, so let's see. Regarding OPC UA interfaces to PLCs and other components, how does Iconix deal with less than adequate OPC UA implementations by individual component suppliers?
So that's an interesting question. So yeah, OPC UA is a great de facto standard for the manufacturing space. The implementation for OPC UA has been perhaps a bit slower than the implementation for OPC Classic, which came out in the 90s. But in the last few years, we've seen a lot more adoption of OPC UA as a standard directly in a PLC or in the hardware. Ultimately, it's a standard that is, in many situations, a self-tested standard. So if there's incorrect or insufficient implementation of it at the hardware level, typically that's where we would look to, obviously, to the original manufacturer. But if that doesn't get us anywhere, we'd look at other protocols, Modbus communications. Perhaps there's a more native communication that they'd be familiar with, and then we could use a on the market kind of OPC server as a converter to access that instead.
Okay, well, if no one has any more questions for Jotham here, you guys can feel free to stop by the Iconix booth and speak with him some more. We still have another session today for you guys to attend, but he is here to answer your questions in the booth. And if you need more information, we will be posting information on ISA Connect for members to look at as well. Jotham, did you have anything else you'd like to add?
That's all I had for here. Yeah, like you said, I'll be at the booth for the afternoon, and I apologize. I was speaking a little quickly to make sure I covered it all for you guys here, but I promise I'll speak a little slower if you come by the booth. So yeah, love to have any conversations if anybody has any questions.
No problems. We'll just direct everybody over there, and everyone can continue along with the program. Jotham, thank you for joining us today, and everyone, thank you for joining the session, and I hope you continue to enjoy the IIoT and Smart Manufacturing Conference.
Excellent. Thanks all. Thanks, Morgan.